Hello and welcome back to our first maths lesson of this week. And we're going to continue our work on division and thinking about what happens when a number doesn't completely fit and is equally divisible by a number. We're just going to stick with 2 digits by 1 digit just so we get the idea in our head. And then when we move forward, it means it's slightly easier for us. So the first thing we're going to do is we're going to think about some questions just to get you started. So here I've got 21 divided by 7, 22 divided by 7, 34 divided by 7, and 35 divided by 7. I want you to have a think about it, use your times table knowledge, and think what you might have to do if there is a problem. Pause now and have a go. Okay, so our first answer is 21 divided by 7 is 3. And this is quite easy, as 3 times 7 is 21. When we get to 22, we can fit that 21, 7 times 3 in, but then we're left with 1. So how we write that is 23 remainder 1. And this remainder 1 tells us how much is left over. It's interesting because what we have the problem of is making sure that this shows what's left. And we'll come to the importance of that a little bit later on. So the next one after that is 34 divided by 7, which is 4 remainder 6. Because what you're looking at is 35 is 5 times 7, so we can't quite fit that in. We don't have enough. Whereas 28 is the next one we can have, which is 4 times 7, and we're left with 6 more. Then we've got 35 divided by 7, which is 5. And this kind of hints at what we're going to be doing today, and that's the using of these remainders, but looking at what this happens when the number is beyond our times table knowledge or goes beyond 10 times that number. So here we have 75 divided by 10. And we can use the same method that we used yesterday to help us. So we evenly split the tens as evenly as possible into 1 into each. And you've got to remember that because we're dividing by 6, we have 1, 2, 3, 4, 5, 6 sections to split them into. We split our tens equally, and that leaves us with 1 10. This 1 10 needs to be split into ones, and then those ones are split evenly 6 times into the 1 section. So if we were to show this using our part whole models, we've taken 60 away. This is our group of tens. And I said that's normally the first chunk. We see whether 6 times 10 fits in. So 60 does fit into 75. So we've got a group of 10 here, which you can see is here. Then we say, what have we got left? And we've got 15 left. So 15 divided by 6 doesn't go entirely. So you can see here, we can fit 2 in. 2 times 6 is 12. 2 times 6 is 12. So we can have 2 of them. And we're left with the ones that we can't evenly split is here, which is 3. And that's our remainder that gets added on to the end. So the total answer to this question is 12 remainder 3. And this is it. This should be written here. This is the easiest way to do it. We use the same principle that we used on Friday, and we think about, okay, can I take a chunk of 10 out? If I can take a chunk of 10 out, that gives me this 10. Then I have a look what else times table knowledge I know in order to get the next chunk. That gives us this bit, and then whatever's left is in here. So here you go. Here's 2 more questions. Have a go. Pause now and try them, please. Okay, let's go through them. First, we have 53 divided by 3. So we've taken our chunk of 10 out, which is 30, which is here, 1, 3 into each. So that's our first, that's divided by 3 is 10. That's our first chunk, which is 10. Then we've got 23 left. And what we're trying to do is what's the closest we can fit into there. And we can fit 7 in, so divided by 3, giving away the answer, with 2 left over, because 7 times 3 is 21, so remainder 2. We put them together to get our answer of 10 and 7, which is 17, with a remainder of 2. We do the same for our next one, which is here, 64 divided by 5. So we take our 50 chunk away first. That gives us 10. And then we've got 14 left. The biggest chunk we can actually take out of that is going to be 2 times 5, which is 10. That leaves 4, which gives us a remainder of 4. Then we add those two parts together and we get 12 remainder 4. And you can see there's the 12, and that's what we got left over. So it's 12 remainder 4, and there's our answer. Then we've got 17 divided by 5. So this is just to show you what we mean when we're dividing it. The 10 can't be, this 10 can't evenly split 5 ways. So we exchange that 10 into ones, and we have 17 ones in total here. Then we take groups of 5 out, or split it 5 ways. We got 3 here, 3 in this one, 3 in this one, 3 in this one, 3 in this one. So it must be 3 with how many we have left over. And the amount we got left over is 2. So it's 3 with the remainder 2. Have a quick look at this one. Have a go, see what you think. And the same thing applies here. We have to split those 10s. Obviously, we can't split 2 10s 3 ways. So we have to exchange all of those 10s into ones to get a whole heap of them. Then we think, in our 3 times table, how many can I fit in? And we know that 8 times 3 is 24, which means that we should be able to split them 8 into each of these sections. And that will leave us the difference between 24 and 25 is this 1. So we split them into 8. So our answer is 8 with that 1 remainder. So this is always an interesting thing. We can look at patterns. So 55 divided by 5 is 11. So 56 divided by 5 must be 11 with 1 remainder, because we haven't got a full 5 yet. Then we've got 57 divided by 5 would be 11 remainder 2, because it's 2 more than the closest multiple of 5, which is 55. Then 58 is 11 remainder 3, 59 is 11 remainder 4, and obviously 60 is 11 remainder 5. Or is it? Now, the interesting thing here is the link between the remainder 5 and what you're dividing by. And what this you're saying is, if I've got a remainder 5 and I'm divided by 5, that's just another group. So actually, this wouldn't be 11 remainder 5. Here's my 6 10s. I split them evenly, the 10s. Then I exchange my 10 for 10 ones and put those in evenly. And actually, we get 12 in each row. So the answer would be 12 instead. And that comes down to the fact that you can never have your remainder being the same or larger than what you're dividing by. So the remainder must be smaller than the divisor, and the divisor is whatever you're dividing by. So your remainder can never be bigger, can never be the same or bigger than 5. It must always be smaller. Because if you ever get bigger than 5, that means you can make another whole group of them. So the remainders must be smaller than the divisor. So here's 3 very quick questions. When we're dividing by 7, the largest remainder we can have is, when we're dividing by 4, the largest remainder we can have is, and when we're dividing by 36, the largest remainder we can have is. So actually this is easier than it thinks, because all you have to do is think of the biggest number you can fit, which doesn't quite get to whatever the divisor is. So if you're dividing by 6, the largest whole number that's smaller than 7 is 6. The largest whole number smaller than 4 is 3. And the largest whole number that's smaller than 36 is 35. So when you're dividing by these, that's the largest your remainder can ever possibly be. If it is bigger than that, then you can make a whole nother group and start your remainders again. So here's some questions. I want you to have a go and see what you can do. And pause now and have a go. Okay, so here's our answers. Firstly, Whitney over here is working out 49 divided by 4 using place value chart. So she's divided the 40 into 4 rows because we're grouping in 4s. The 9, she's grouped in 2s, which gets her to 8 with 1 left over. So this actually is the correct method, but there's 1 counter left over, and that's what we call the remainder. So the answer is 12 remainder 1. And you can use that same thing to do 50 divided by 4, just 1 additional counter. We haven't got to a whole nother group, so it'd be remainder 2, and 51 will be remainder 3. Just increase, the remainder increases by 1 as our starting number also increases by 1. The next one, if we're doing 52 remainder, 52 divided by 4, it would be 12 remainder 4. Now, we've just talked about this. We can't have a remainder of 4 because that's the same as our divisor, which actually means that that's a whole nother group. So we'd actually get then to 13. Next one over here. Hopefully these are all straightforward. We are just looking at how many you can fit into this number and how many you have left over. And the same goes down here. You're just looking at that pattern again of what happens and showing the fact that you can't have a remainder larger than your divisor. So Dora's been working out some calculations and she's got them here. 72 divided by 4 equals 18. And he keeps going. Now she says she knows that without working it out, that 76, the next in her pattern divided by 4, must be 18 remainder 4. Why does she think this? And explain why she's wrong. Have a go, and we'll come back with the answer in a second. Okay, so she spotted a pattern, which is why she thinks that. And she thinks it because every time this number increases by 1 here, so does our remainder. But the problem is, she's wrong because you can't have a remainder of 4 when you're dividing by 4. You can't have a remainder the same or larger than your divisor. It has to be smaller than. So apples are packed in bags of 8. Here's 1 bag. Dexter has 91 apples. How many bags does Dexter need so that every apple is in a bag? This is very similar to a lot of reasoning and problem-solving questions that you'll have around division, because what they're looking to do is try and catch you out. So what you would do, have a work out the answer, use place value grid if you need to, use your part whole model if you need to in order to get to the answer. Pause now and have a go. Okay, so 91 divided by 8. Let's put that into our place value counter. We got 80. We can divide equally there. This is our group of 10. Then we've got 11 left, which we can split evenly by putting 1 into each. And we're left with those 3, that remainder 3. So our total answer is going to be 11 remainder 3. And it says, how many bags does he need that every apple is in a bag? Well, the problem is if we say 11 bags, which would be in essence, this is the first bag, second bag, third, fourth. No, then 11 bags because there's 8 in each. So it works slightly differently. We then have 3 left over, 3 that wouldn't be in a bag. Now that can't be fair, that can't be. So we actually need another bag for those 3 to go in, which is why we actually have to say 12 bags. That remainder still needs to be placed somewhere. Here's some more questions. Have a go at these, and I'll come back to the answers in a minute. Pause now. Okay, and here are your answers. The first one is this first question is very similar to what we've just done, thinking about how many boxes that you can put them in. She can fill 12 boxes and she'll have 3 eggs left over. She can't actually fill that last box because that 3 doesn't fill it. And on this side here, what you're looking at here is there's the number of bulbs that you have here. He's going to put equal number of each bulb into 4 tubs. So you're going to divide each number by 4, and your answer are these here. But in each case, you have some remainder, which is this bit here. The question then, this last bit of the question is a little bit harder. It says, how many tubs could Jack use so that there's no bulbs left over? So when looking at this, if we're trying to do that, we have to think about a factor that goes into each of those numbers. So what times table is 49, 63, and 98 in? And the answer is, we'll find out in a minute. Then you pick the highest common factor. So you look at the factors, you look at which times table they're all in, the highest one they're all in. And the highest common factor is 7. The rule divisible by 7 is the largest one you can do. 49 divided by 7 is 7. 63 divided by 7 is 9. And 98 divided by 7 is 14. So that means that the most boxes he needs 7 boxes so that none are left over. Okay, that's all for today. I know it can be quite confusing, but try your best. If you need to go back and look at it again, please do. You need a firm grasp of this because it means that later on division becomes much, much easier. Thank you, and we'll see you in the next video. Goodbye.